Hello everyone, myself Hans. Today we are going to solve the given problem from topic partial differential equation. Question is given here. Eliminate the arbitrary function and obtain the partial differential equation, and the function is given here z is equal to f of xy upon z. Here three functions are given here. Given function is z is equal to f of xy upon z. Let this equation 1. Equation 1, partially differentiating with respect to x, we get here del z upon del x is equal to f of xy upon z differentiating with respect to x. This gives f dash of xy upon z. And when we have to differentiating with respect to x, taking y as a constant, then again xy upon z differentiating with respect to x here, and y is taking constant, then x upon z we have to using the division rule. Division rule is given by u by v, del upon del x is given by v my differentiation of first function minus of u, and again differentiation of second function upon v square. So we have to use this following formula here. U is x and v is z. So we have to write here z, and del upon del x is x minus of x, and del x upon del x is z upon z square. This gives and we also know that del z upon del x is p, and del z upon del y is q. In partial differential equation we use the following, and further we have to write here del z upon del x, we have to putting here p is equal to f dash of xy upon z, and here in the bracket y is taking outside, and del upon del x differentiating with respect to x, this gives 1. This is z minus of x, and del z upon del x is written as p upon z square, and we can also write this is p is equal to f dash of xy upon z, and this is multiplying with y, this gives, and taking denominator is part, this gives y. Once again y is taking outside, and z upon z square, and minus of xp upon z square. Z to z is cancelled out here, remaining is here z. Then this gives p is equal to f dash of xy upon z, and in the second bracket this is y upon z minus of xy into p upon z square. Let this equation 2. Similarly, when we have to differentiating equation 1 partially with respect to y, this gives, here we have to differentiating, this is del z upon del y, and this gives f dash of xy upon z, and again when we have to differentiating xy upon z with respect to y, taking x as a constant, then remaining is here x is taking constant, and the remaining is here y upon z, and y upon z using the following division formula, this gives z, and del upon del y, this is y minus of y, del upon del y, this is z upon z square. Further we have to solve. Del z upon del y is written as q is equal to f dash of xy upon z, and here is x, and this is z, and del upon del y differentiating with respect to y, this gives 1 minus of y, and del z upon del y is written as q upon z square. Similarly, we have to separate these terms. this is q is equal to f dash of xy upon z, and here x and z upon z square minus of y into q upon z square. From here z to z is cancelled out, then remaining is z here. This gives q is equal to f dash of xy upon z, and we have to multiply with x. This gives x by z minus of xy into q upon z square. Let this equation third. And from equation second and third we have to eliminate the arbitrary function. So once again we can also write here these terms is taken to denominator of p. This is written as p upon x y by z, once again y by z minus of xy p upon z square is equal to f dash of xy upon z. We have to write the equation second in the form of, and let this equation fourth. And we can also write the equation third in the form of, this is q upon, this part is taken to denominator of q, this is x by z minus of xy q upon z square, and this is equal to f dash of xy upon z. Let this equation fifth. And from equation fourth and fifth we have to comparing the equation fourth of right hand side and equation fifth of right hand side are equal. Then the rule said if the right hand side are equal, the both the equation, so we have to take in the left hand side is also equal. So we have to write in here equation fourth of left hand side is p upon y by z minus of xy into p upon z square, and equation fifth of left hand side is q upon x by z minus of xy q upon z square. So we have to arrange the following terms and solve further. We get the required solution. Cross multiplied here, this gives p multiplied with these terms. This is xp upon z minus of xy pq upon z square. Similarly here q, these terms multiply with q, this gives qy upon z, and minus of xy once again. Here we have to write mistake in here. Equation third of left hand side is xyp here. This is p, and multiplying with q, this gives xy pq upon z square. And from here we can also once again xp upon z is equal to minus of xy pq upon z square is taken to right hand side. This gives qy upon z minus of xy pq upon z square, and this terms is taken to left hand side. This is plus of xy pq upon z square. So we have to cancel out here. Xy pq upon z square is minus, and here is xy pq upon z square is plus. Then we have to cancel out these terms. Then remaining is here xp upon z is equal to qy upon z, and z to z is also cancel out. So we have to write here xp minus of qy is equal to 0, and we can also write this is qy minus of xp is equal to 0, and this is the required solution of the given problem. Thank you class, and thank you for watching.